Hello and welcome to Postgres FM, a week's show about all things PostgreSQL. I am Michael, founder of PG Mustard. This is my co-host Nikolay, founder of Postgres AI. Hello, Nikolay. What are we talking about today?
Hi, Michael. Let's talk about search at high level. But before we proceed, let me express a few words, a few thoughts about the news we've got a couple of hours ago, about Simon Riggs. We are recording this on Wednesday, March 27, and Simon Riggs just passed away. I remember him as a very bright mind. I remember he was not an easy person to deal with, obviously. I remember like 100 emails, even 100 emails to convince him to come to Moscow to speak at conference. Many people involved, but eventually he did. He came and it was great talk. But the work he did and like in general, it's a big loss, obviously, for Postgres community. So, condolences to family, friends, and co-workers, ex-co-workers, and so on. And Simon built a lot of things, and he was quite brave to attack very complex topics in Postgres system in general, right? In core of Postgres and in the engine itself. For example, point-in-time recovery, things related to replication. Many achievements were made by Simon or involving Simon. So it's a big loss, definitely.
Yeah, over many years as well, right? I only actually had the opportunity to meet him a couple of times at a couple of London events and heard him speak. And not only was he a great contributor to the code base, but I was amazed at how he was able to communicate and educate and also community build, right? Like he was involved in organizing a lot of events, especially in the UK, growing companies and a lot more around the ecosystem as well.
I must say, I remember very well this look in Simon's eyes, which was like had some sparkles. And I remember the conference, the very first conference in the American continent I attended in 2007. Speaking with Peter Eisendrath, I was a baby actually. Like I was like implemented some parts of XML implementation functions and type in Postgres, and I remember Simon looking directly to me with those sparks and asking, "What's your next thing to build in Postgres?" I was caught out of guard, didn't answer anything actually, and so this is what I remember about Simon. This look and courage. Do I pronounce it right?
Courage, yeah.
Courage, yes. He obviously had big courage, huge. So.
And the ability to silence Nikolay, that's quite the
skill. Yeah. It's interesting, yeah. So it's sad, very sad. So, yeah.
Yeah, absolutely. Condolences to everybody who knew him and worked with him. I don't really know how to move on from that actually, but we were going to talk about search, right?
Let's just, after this small break, let's return to the search topic. And it's a very wide topic. And I guess we just want to touch it a little bit today at a very high level, right?
Yeah, well, it's amazing if you consider all the things Postgres is used for. Search is one of like the top use cases, but looking back at our episodes, we've touched on it a few times, like when we've looked at using external databases or forgotten what somebody called them actually, like a second type of database, like a partner database or something like that. So we touched on them a few times, but never, we haven't done anything on full text search. We haven't done anything more recently on semantic search. We've done like a PG vector episode and a few kind of related-ish subjects. But no, it crossed my mind that we hadn't touched on this really as a topic. And obviously, it's one of those subjects that the more you learn, the more you realize you didn't know, or the more complicated it gets. So I can imagine us doing quite a few follow-ups on the more specifics or, implementation details or the tricky parts. But yeah.
Don't forget faceted search, right? There's such term,
faceted,
right?
Yeah. I could be saying it wrong, but I think I've heard it called faceted. Like drawing bitmaps and things like that.
Well,
Is that
usually we start from UI. And in my head, this starts
sure,
from
sure?
in UI. We have some like things in big form of consisting of multiple, very different selectors and filters and so on. And we just this is very common in very various marketplaces. Or for example, imagine Airbnb. You want to limit price and location and various categories and properties and so on. And let me put this on the table right away. Ideally, we always should have just a single index scan or index only scan. This is our ultimate goal always, but unfortunately, it's not always possible. Why do we need it? Because it's the best plan, and I think you can like. Do you agree or no? Because you deal with plans all the
No,
time with PG Master to explain plans and so on. Like
yeah.
single index scan is the best.
One of the things I love about databases and performance in general is when it gets to the point where you have to trade one thing off against another. And I think search is one of those topics where often we're trading off user experience versus complexity of the back end. Or so like some of the nicest search features are just a search bar, but without getting any input from the user, you have to do a really a lot of work on the back end to be able to serve that in any kind of performant way. So you've got the complexity of matching the results to the intent, with the additional caveat that you want it to give at least some results, good results, quickly. And that's a trade-off. Like it's really easy to get, well, not easy, but you can give great results if you can search through everything you have and score everything, and if you've got forever to return them. But if you've given yourself a budget of returning within a few hundred milliseconds, suddenly that becomes a more difficult problem. So I love that it's a trade-off, and we're trading off user experience with resources, with technical complexity on the back end. So I think it's one of those topics that there are trade-offs, and yes, one of those is performance, but sometimes I think you are willing to pay a little bit of performance for a better result.
Well, yeah, this is difficult, I guess. What is better results and what is like high quality of search, right? Like I remember definition that users should be happy, which is very broad. Like, what makes users happy? Like maybe we return good results, but UI is very bad, so they are not happy, right? Like it's quite interesting topic, and I think you're right, but also like I just dove into the very bottom of performance. Like performance matters a lot, right? If search is very slow, the users won't be happy, and it means poor quality of the search, right? So we do care about performance, but also we do care about things like if we take full text search, we want stop words to be removed and ignored. We want some dictionaries to be used, maybe synonyms to be applied, and so on and so on, right? This matters a lot, and of course, but this also moves us to performance part, because if these steps are slow, it's also bad. Well, why I was mentioning faceted search, I just see a common pattern. Postgres is huge in terms of capabilities and extensibility and various index types, extensions, but we have simple problems unsolved. For example, take full text search and order by timestamp or ID. I want the very like instead of old school regular approach, return like most relevant documents to me. I want fresh documents to go first because it's social media, and this is number one pattern. But also they need to follow some full text search query I used, right? I just need to see the latest, but following some text patterns. And this problem is unsolved in Postgres, unfortunately. And there is the best attempt to solve it. It's called RAM index, which is extension like a new generation of gin index. But why isn't it in core? Because it has issues. It's huge, it's slow, and so on. And similar things I now observe, and not only observe, I touch them. For example, just before we started recording, you showed me the Supabase blog post about
Yeah.
how to combine full text search and semantic search based on embeddings. I don't like the word embeddings. I like the word vectors, because embedding, in my opinion, like in database, I cannot. It doesn't settle in my mind at all. Embedding is what we embed to our prompt. This is content, but vector is vector. I like.
Yeah.
Maybe I missed something, but why do we call vectors embedding? Honestly, in our database, this column is called embedding just because OpenAI dictated it. But I also see OpenAI assistance APIs name state machines states as status, which also like, what's happening there? It's status. Status is state machine, state, like in progress, function call, etc. So, but it's off topic. So these vectors, they provide us great capability to have semantic search, and we have text search. And supervised article describes how to combine them. But basically, we perform two searches and then like merge results. It means we cannot do pagination. Pagination is very important. Maybe user needs to go to second page, third page. In quality search engines, they do need it. And in this case, it means that it's similar to offset problem we described many times.
That's the only solution, I guess, is
so far, yes, but
pagination
maybe
through
it's
offset.
possible to combine something, right? Honestly, Gene is also about multidimensional things, and like I don't know. It also has KNN. I don't know. Like I know only parts of things here, but what like I don't like two index scans and then we combine things and we lose pagination. I mean, we can have pagination, but if we want to go to page number 100, it's insane how much data we need to fetch, and buffers will show very bad numbers and analyze buffers. It means it's not working well. And different example. Sorry, I will finish my my complaining speech. So different example is what we have right now. In our bot, we imported more than 900,000 emails from 6 mailing lists, 25 years of them. So we have more than 1 million documents. And of course, immediately, like before, we'd only imported to the bot's knowledge base only documentation, source code, and blog posts. And all of them were quite relatively fresh, almost. But when we imported 25 years of mailing lists archives, I'm asking, hey bot, what can you explain me about subtransactions? Okay, this is documentation, my article, but also there is a very good email from Bruce Momjan from 2002. And it went to first place. It's not good. We need basically we need to take into account the age of the data here, right? How to do that? There's no good way. If you work with PG Vector, there's no good way to deprioritize old documents to take into account the age of the data. So what we did, we just usually we need to find like 10 or 15, 20 entries, maximum like 100 usually entries, and embed them as embeddings to the prompt. So what we do, we find 1,000 entries. And then just in memory, Postgres recalculates adjusted similarity, adjusted distance based on a logarithm of age. Right? And this is how we do. Like, if nothing new, okay, we are satisfied with old documents. But if there are so we take into account the age, right? But again, this doesn't scale well. Like, if we will have a lot of like 10 million documents, it will be worse. And also, we cannot have pagination if we talk about search here, right? Kind of similar problem as well. And this makes me think, great that we have extensibility, but these types of search are so different. We have like what is the name of when different things are combined? So it means that it's hard to build good
Are you
system
talking
which
about
works. Yes, heterogeneous. This word
yeah,
I know how to spell it, but I cannot pronounce
yeah.
it because I saw it many times in papers, but
Mhm.
in scientific papers and so on, in technical papers. But yeah, pronunciation
I'm
is
not even
not
sure
my
I know how to pronounce it.
strength.
Heterogeneous or something like that.
Yes. I cannot pronounce it in Russian. Sorry.
Yeah.
So what I'm trying to say, we are kind of Linux early stage. You need to compile a
Well,
lot of drivers, like, and deal with it to make system work as you want, like as good product, right? Compared to some things like Elastic, when you take it and
yeah.
things work together very well because it's single product. What do you think about it? This is a problem.
Well, I think
Extensibility
you've
has negative side here.
I think you've jumped straight to like where are the limits of Postgres's search capabilities right now, and that's a really interesting topic and quite deep already. But it skips over all the things you can do already in Postgres, and there are a ton of different like
Yeah.
inbuilt things or add-on modules or extensions that mean that those limits are being pushed further and further. And I think a lot of people come from an assumption that Postgres won't be able to handle search super well because products like Elastic exist and are successful, and therefore probably people aren't doing this in the database. But I see a lot of use cases that can be served adequately with good results in acceptable response times for users without touching any external services. So I think you're right that there are edges and there are limits that can be better served by other products, but those limits are quite far down the road for a lot of use cases. You can build pretty good search features for a lot of different use cases, especially if you're willing to learn exactly how it works and factor in your own product or services requirements. If you're not just searching every field for every word or like I'm assuming like a text search type field, it can be really powerful already.
Yeah, I agree. But yeah, well,
Can we talk about some of them quickly, like just to
yeah,
cover the
let's talk
basics?
about them. I agree, and you're like basically echoing the usual problem I have. Like people, so I had the cases when people listening to me said I'm a Postgres hater, right? So again, of course, this criticism is goes quite deep, and of course, like I don't like the idea to have elastic search for full text search and the need to constantly synchronize, or maybe some what's the names of these new vector database systems, Pinecone or something like that. So you
Yeah.
basically need to synchronize the data from your main OLTP database all the time, and you have a lag, and then you bring some regular data there, and you think how to combine and search that data, because obviously for Elastic, this like you need to not only bring textual data, but you need to bring categories to have the same faceted search. Sometimes people want, like, I want to do full text search, but again, limit price, for example, right? Some range, and this usually is stored in a regular column in the relational database. And of course, we have good capabilities to combine it with full text search and achieve in the single index scan. For example, if you use GIST index, well, GIST is slower. It works well for smaller data sets, but you combine it with GIST B3 and GIST B3, right? Or yeah,
B2 gist, I think. Yeah.
right. So, and then you have a capability to combine both full text search and numeric range filter
Yeah.
and have a single index scan. This is perfect. Again, I'm staying on the same point. Single index scan is the best, but unfortunately, in many cases, we cannot achieve it. Ideally,
Oh, I
user
couldn't
types
agree.
something, chooses something on the form, press search, or maybe it's automated. Like I don't like automated. I like to press search explicitly. Anyway, we have request, and this request translates to single index scan, and we return. And this is an ideal case in terms of performance. Otherwise,
Yes.
or for bigger data sets, you will have very bad performance.
Well, in terms of performance, but also in terms of system resources, right? Like, we're also not having to use a lot of system resources to satisfy quite a lot of searches, whereas a lot of the alternatives require, well, because they're not just one index scan, require more resources as well. So I think it's efficient from a couple of angles, but it very much limits what the user can search for. If it has to be indexable that way, some other searches wouldn't be possible. Like I don't know about you, but since to give people a bit of an insight into how we do this, we agreed a topic about 24 hours ago, and every product I've used since, I've been like thinking, how does search work here exactly? And it's really interesting how different products implement it, and not everyone does it the same. And we've been somewhat spoiled as users by Google, in my opinion, Google and Gmail, both of which have incredibly good search features for quite a long time, and most people have experienced those. But it isn't the same in every product. Not every product is firstly capable of doing that, but also it is not quite the right trade-off for a lot of products either. So like a lot of products you use, or a lot of products I use, things like Slack, for example, or Stripe, they will encourage you to use filters. They let you type whatever you want in, and they will perform a wide search depending on whatever you type. But they encourage use of, for example, in Slack, search within just one channel or just from one person, or things that filter it right down to make those searches much more efficient. So it's interesting that they're doing that, partly, I guess, to give you the results you're exactly looking for high up, but also, at a guess, to reduce system use. Like they don't have to do as much work if you filter it down for them.
All right.
So I think there's a few things that the beginners, I think, or when I was a beginner, when I didn't know quite how this stuff worked, I don't think I fully appreciated the complexity of doing search well. So there's the basics. We when we say full text search, by the way, I never really understood what the word full is doing in there. It's basically just text search. Does this document or does this sentence or something contain this word and this word, or this word or this word? And so basic kind of text-based searches. I don't know why it's called full. Do you know?
No? Good question. I think, right, so I understand the difference. Like, you can compare the whole value, in this case a bit easier now, but you will be dealing with the problem of the size of this value, right? And then,
but there's like a million complexities. Just if we only consider that, there's a million complexities to do. Like, should you care about the case of, like, does the
right.
do capital letters matter?
So full text search is a very well established area
Yes.
already, and where instead of comparing whole value or doing some regular expressions, right, which is also interesting topic, but it's also related. Like a gene can be trigram search can be used, right?
Yes.
Instead of that, we consider words. Like, first of all, we, as usual, have this problem with first normal form, but it's off topic, right? Because this value is not atomic anymore, right? We consider each value as like we have atoms in this molecule, right?
Yeah.
So and first of all, some words we usually either normalize using this snowball stemmer, right? Or we use some dictionary to find kind of
synonyms or like.
No, synonyms is one thing. It's also synonym dictionary can be used, but I'm talking about iSpell dictionaries, for example, when you take when you take a word and stemmers is very dumb. It's just cut the ending. That's it. You can feed some new word and it will cut it according to some rule. But iSpell, it's a dictionary. It knows the language. It knows the set of words, and it can transform words in different forms to some like normalized. It normalizes every word, right? And then we have basically we can build either a tree and use GIST, generalized index search tree,
Yep.
which can be used for even B tree or R tree. By the B tree is one dimension, R tree is two or more dimensions, and R3 is based on gist in Postgres because implementation based on gist was better than original implementation, which
Cool.
was not the case for B3. B3 remained the native implementation, but there is gist implementation. That's why I already mentioned it, right? And then, so tree, right? Great. So you can find the entries which have your words, but also you can, there's an inverted index, gin,
Yep.
right? And gist actually, gist, I didn't mention. So B3 is one dimension, so just one axis, R3 two or more dimensions, and you can build a tree for example, rectangles in two dimensions. But what to do with text? Because it has a lot of words. We can consider words as kind of array or set, right? And then we can say this set contains that set, right? Or is contained. So we define operators intersects, is contained. And in this case, we talk about sets, and we can still build the tree based on gist. There are 7 functions you need to implement to define the operations, and like basically, so for sets we can build tree, and it's called actually RD3, Russian doll tree. This is how full text search, its official name for Berkeley paper. We can attach the link to it. And this is how originally full text search was implemented for based on gist. But also later it was implemented GIN, which is generalized inverted index, which works much better for very large volumes of data. And this is what search engines use. So it's basically the list of terms and links to in which document terms are mentioned, and then there are internal B trees to find faster each term, and like so. I think there are two kinds of B tree inside GIN, but it's like implementation details. So in general, it means that we can say, okay, these words are present in this document, right? And we can very fast find them. And we can also order by like rank. Rank, it's interesting thing. It's calculated based on like most relevant documents. Like for example, I don't know, like words are like mentioned more in this document, right? Do we have
Yeah.
phrase search? Can we do double quotes? And yeah, we have also
So,
some
well,
and or some we can write some formulas,
there's like
right?
followed by. Yeah, you could do like followed by for phrase search, but there's also we have some data types and loads of functions that are really helpful for doing this
And
without
4
much work,
categories,
like
right? A, B, C, D, right? We can, yeah, you can, when
weighting.
you're,
What do you mean by
I
categories?
don't remember. I remember when you define gene index, you need to convert data using two TS vectors. So you convert to special text search vector, TS vector type, and you can say that some parts can be considered one category, some parts different category. There are maximum 4 categories. And when you search, you can say, I'm searching within only specific category. It means that, for example, you can build one TS vector, but take, for example, if you're indexing, for example, emails, you can take words from subject and mark them as category A, for example, right? But body is B. And then you have freedom and flexibility to search globally, not taking into account the origin of the words, or you can limit inside single same gene same search. You can limit saying I'm searching only inside subject. And you can mark these parts of TS vector, and which is good, but 4 is not enough in many cases, right? So there are many capabilities developed in full search.
Yes, and you don't have to build that much around it to get something pretty powerful out. And one thing I learned about relatively recently from a blog post was web search to TS query. So there's TS query being the query representation, and the TS vector being the vector representation, like the normalized. So once you've like taken each word, normalized the like plurals out of it and things like that. But yeah, web search means you can achieve a query that is a bit like you might imagine a fairly complex search engine search, like taking like the not operator and saying, I don't want documents that include this word, or using and or type operators as well. So it could let you build something that has some basic search engine like features built into the text search field without much work at all. So, and these all come like in Postgres core, right? You don't even need an extension for this lot, which is pretty cool. But yeah, I was going to move on. I think obviously that contains loads of complexities and helps you solve some of the trickier things immediately. But there's also relatively inbuilt modules for fuzzy search. So like handling typos elegantly, or like the kind of things that just start to get a bit more complicated. Do you want to be able to match on people nearly getting the name right? And not all products do, but it's pretty common that we do want to. When I first came across Trigram Search, or PG Trigram, the extension, I was blown away by like how elegant a solution that is to typos. So were you not as impressed? Like I was thinking, it's so simple and it works so well.
Trigrams. Well,
Yeah,
let me disagree with you. I use it many
go
times
on.
for many years, and I cannot say it's elegant because it requires, first of all, it requires a lot of effort. It's not just you say, I want trigrams here, that's it. No, you need to do something, like some things you need to do. And also at really high volumes, it doesn't work well in terms of performance.
Sure.
And if you have a lot of updates coming, you will bump into this dilemma,
The
fast
gin
update
issues.
or without fast
Yeah.
update gene, and pending list, which is by default 4 megabytes, right? And during regular select, it decides it needs to be like processed. Select is timing out. Then you need to tune it. Well, I still have feeling it could be better.
No doubt, and I guess this is the one of the examples of can work really well for a while, and once you like at a certain scale, maybe an external system is beneficial. But yeah,
Yeah, because it's more polished. But also, I think there is opportunity for people who are new Postgres companies to
yeah, true.
improve and benefit from a more polished version when you develop some product on top of Postgres, right? So
Yeah, and there are some startups, right, that are quite focused on search, or at least what is it, Parade DB, that are looking into this
right,
stuff. And then
maybe
there's
you're right. Yeah,
there's also one other that's worth. What it'd be a shame to finish this episode without mentioning them.
ZomboDB.
Yes, who do synchronization, who take the hard parts out of synchronizing Postgres with Elasticsearch.
Yeah, I saw good target. Also, I wanted to mention. Sorry, I was trying to find the book I recently bought. For specialists, it should be super like important book, I guess. And I need to thank Andrei Borodin as usual. This guy helps me a lot with Postgres and in general. So this book it's called Introduction to Information Retrieval by Christopher Manning, Prabhakar Raghavan, I'm sorry, and Henrik Schutze. So this book is interesting, and this is exactly where I saw this, like, what is good quality? Users are happy. And then a lot of formulas, right? It's interesting.
Well, and it's a moving target. One of the good blog posts I reread as part of doing research for this was by Justin Searles about a Ruby implementation. And he made a really good point at the end about it being a moving goalpost. So users might be happy with waiting a few seconds 1 year, and then 5-10 years later, that may not be considered good enough anymore because they can use other search engines that are much faster. Or your data volumes grow. You talked about, if your implementation relies on volume might change, but also patterns might change, and you might find it's harder to provide as good results as your data changes or as your users change in their expectations. So it's kind of a moving goalpost constantly as well. So not only might the same results 10 years later not be good enough, but also
Right.
like yeah, well, yeah, it's a tricky one. But I think user happiness is one good one, but also like Google uses lots of
You know,
metrics like
yeah. You know what I
well
think
things
right
like
now? Uh-huh.
go on.
So since we talk about semantic search, which supports some like a kind of AI systems, like these embeddings, I'm thinking about not user happiness, but AI happiness, LLM happiness, so to speak. So, and I think that usually we deal with very large documents, and when we generate vectors, there are certain limits. For example, OpenAI limit is 8,220 tokens, 800, roughly like 15, 16 characters. And for example, my article about subtransactions, it exceeds 30,000 characters. So it was hard to vectorize it, right? And we needed to summarize it first using LLM and then vectorize the summary only. So that unfortunately, right, it works okay. But what I'm trying to say, when we talk about traditional search engines, search results are not whole documents; they are snippets.
True.
And it's also it's a part of this happiness or quality is how we present results. For example, we can provide snippets and highlight the words which are present in the query, right? It's good. It's good for user experience. The user immediately sees the words mentioned that user typed. It, like if it's a synonym, it will be like different, but anyway, like it's a good practice. But if you think like about Google, how it works, you see some results, second page, first page, second page, and so on. But then like it's good when very relevant results are on the very first page, right? Maybe on the first top, like included in the first page, and you're satisfied. We like there is new topic, LLM happiness. They should be satisfied. But what does it mean? It means that what we decided to include, to embed, to prompt and use in answers should be very relevant, right? And this is very big topic which is not yet discovered properly. In my opinion, what I have in my mind, I'm just sharing, and if some guys are interested, like I would love to have a discussion around it. So what I think, this is what we are going to do. Not yet, we are going to do it. We are going to return many snippets or summaries or something like, not whole documents, and then ask LLM internally during the same cycle of request. We just say, LLM, evaluate, is it relevant? Do you think based on this snippet, is it relevant to your original request, right? And if it, like on the scale from 1 to 10, and we limit the result, and then it's important, and this is how we humans behave. We open each document and inspect it fully and think again, is it relevant? And only then, and maybe we go to second page. I don't know, like maybe second page is not needed. We just, our first page can be bigger because it's everything is automated here. But we inspect full document and decide, is it worth keeping in using in the answer or no? Maybe no. Maybe in the end of this process, we will have 0 documents left. Maybe we need to think maybe to provide different query. And what I see from LLM, sometimes if we do this, like you ask something, there is this RAG system which performs a search, and you are not satisfied. And if you just tell, like if you consider LLM as a junior engineer, you just say, I'm not satisfied, you can do better. Invent some new searches and try them. You don't say exact what searches to use. LLM can use, and in all cases I did this, I was satisfied on the second step. So I mean, the internal process of searching can be very complex. It might take longer, much longer, but the result will be much better. And the question about quality here is it's shifting. This semantic search should be somehow different to be considered as good quality for this type of process for AI systems. So I'm reading this book, understanding that it was written for search engines targeted humans, and I'm very interested how this topic will be changed. I'm sure a lot of things will be inherited. A lot of science is there, like huge science. Search engine, like information search, it's a huge topic, right? So a lot will be inherited, but there will be changes as well because of high level of automation, LLM, like and I'm very curious how quality will be changed. So this is a very interesting topic. And I have many more answers, many more questions than answers.
Yeah,
Yeah. Thank you
as
for
usual.
listening this long speech. It just sits in my head
Well,
right now. Like what will happen
don't
with
you
search?
consider don't you consider search engines semantic search too? Like,
Kind of, yeah. Well, Google, it's known, and all top search engines, they do semantic search for
yeah,
many years already. I know that, but now we like they didn't provide, like, do you know API to Google? I don't know. I only know some workaround solutions to it, right? But now we are building small Googles for our small knowledge bases, and it's interesting. What, like, pgvector is a very basic thing. Of course, a lot of work there, a lot, like, two types of indexes it provides, and so on, performance improvements. But what to do with age, what to do with this embedding process? Yeah, these questions are big right now in my head.
cool. I'm looking forward to some in-depth ones on this one,
Yeah,
diving into these
I hope we
specifically.
will have some follow-up episodes, maybe about full text search as well,
Yeah,
and semantic search as well, and so on, faceted search as well.
absolutely.
Yeah, good.
Sounds good. Right. Thanks so much, Nikolai. Take care.
Thank you.